Hello everyone, and welcome to the lecture on self-join. In this lecture, we're going to learn how to use a self-join statement, see an example in the slides, and then we'll see another example of PostgreSQL and pgadmin with the database we've been working with. So you've already learned how to join a table with other tables using things such as an inner join, a left outer join, or right join, etc. However, there is a special case that you join a table to itself, which is known as a self-join. You use self-join when you want to combine rows with other rows in the same table. To perform the self-join operation, you must use a table alias to help SQL distinguish the left table from the right table of the same table. And what I mean by alias is using that as statement. So remember, we were able to call whole tables or whole columns something like column ID as some other name or some alias name. That's what we're referring to when we say table alias. And you'll see examples of that as we go forward. So imagine we have the following table. We have one column with employee name and another column with employee location. And we can see here that Joe is from New York. Suppose we want to actually find out which employees are from the same location as the employee named Joe. So if we quickly scan this table, we can see at the bottom there, Jack is also from New York. So we want to find out which employees are from the same location as the employee named Joe. There's a couple ways to do this. In this example, like I mentioned, that location that Joe lives in is New York, and let's assume that we cannot just directly search the table for people who live in New York with a simple query like this. So maybe we don't want to hard code the city name in the SQL query, etc. And what I mean by that is, let's imagine that we couldn't just do this. We can't just say where employee underscore location equals New York. For some reason, we just can't directly put in our query where employee location equals New York. And there's a bunch of real-world scenarios where that's going to be the case. Either you don't want to have to look it up again, or you don't want to have to run two queries, etc. So let's just imagine, for the sake of argument, an example here that we can't write that bottom line exactly like that. In that case, we have some other options. We could use a subquery, and we just saw that earlier in some lectures, specifically the subquery lecture, where I could say select employee name from employee table, where employee location in, and then I have my subquery there in parentheses or round brackets. And then I'm saying select employee location from employee, where employee underscore name equals Joe. And that will bring back New York, and then I'll do the other query into the subquery, and that should then bring back Jack. Okay, so that's one way to do it. And while a subquery is a valid solution, it is actually more efficient to use the self-join that we're learning about. So we're going to join a table to itself. Again, as a general rule, we need to always use aliases, so remember the as statement, when using a self-join. So for that particular example, it would look something like this. I would say select E1.employee name column from employee as E1, comma employee as E2, where E1.employee location column equals E2.employee location, and E2.employee name is equal to Joe. And so notice here the actual syntax of this SQL query doesn't specifically use any of the terms join. And that's because it's a self-join. So because I'm using this aliasing technique, saying employee as E1, comma employee as E2, so I basically have two tables in there with from as two aliases, but they're actually the same table, employee. This is known as a self-join. So again, I'm saying select the employee name column from E1 from employee as E1, comma employee as E2, where E1.employee location is equal to E2.employee location. So where that employee location matches, and where that employee name from E2 was equal to Joe. So let's go ahead and break down a little further what this is actually doing. So again, this query is going to return the names Joe and Jack, since Jack is the only other person who lives in New York like Joe. And generally, queries that refer to the same table can be greatly simplified by rewriting the queries as self-joins. So if you compare the subquery text to the self-join text, there's a lot less text in the self-join, so it looks a lot cleaner. And in addition to this, there's a performance benefit as well to doing a self-join versus doing two subqueries. So let's go ahead and break down what that self-join is actually doing. Let's go ahead and recall our original table where we have the employee name and the employee location. And then, again, remember that Joe lives in New York and Jack lives in New York. So then we've created two aliases, E1 and E2, and notice they're the same table. So they're both instances there of the employee table, there's just aliases. And then the final result of running the self-join query above, the actual joined table would look like this. You'd have the E1.employee_name column, the E1.employee_location column, self-joined to E2.employee_name, E2.employee_location. So you would get this as your actual joined table. And this is where you actually call the columns off of it. So if you remember, the columns we called off of it was E1 there. And the reason we get two instances of Joe here is because if you look back to the self-join query, we had that AND statement that said and E2.employee_name is equal to Joe. Okay, so that's what the actual join table looks like when you return it off of self-join. So let's go ahead and see an example in pgadmin to work with our database and get some more understanding of how this self-join is actually operating. I'm going to go ahead and jump to pgadmin now. Okay, so here we are at pgadmin, and I'm going to go ahead and be using the customer table. So let's go ahead and remind ourselves what the customer table looks like. We have a first name and a last name of a customer, and then some other information on them. I'm going to be specifically concerned with the first name and last name columns. Let's go ahead and imagine that we wanted to retrieve all customers whose last name matched the first name of another customer. Meaning if we had a name like Sandra Martin, and we had another name or another customer whose first name was Martin and last name was something like Bales, then we'd have a match there. So we'd have Sandra Martin matches with Martin Bales. So we want to retrieve all the customers whose last name matches the first name of another customer. And the best way to do this is using a self-join. So let's go ahead and explore how we can do that. So I'm going to say this. Select the a.first_name column, and we'll say a.lastname column, and then we'll say b.firstname column, and b.lastname column. And I'm going to select that from the customer table, but remember I have to use aliasing here. So I'm going to say from customer as A, comma, customer as B. And then we're going to say for the actual join, I'm going to go ahead and use a where clause. So then I'm going to say where a.first_name equals b.last_name. Now let's go ahead and run that. And you'll notice here we get some results. And if we look at them, we can see that our query ended up working. So here we have the first name. Rose Howard shares the first name to the last name of Darlene Rose. And we have Kelly Torres and Denise Kelly. So we see the matches on the first column and the last column. And let's go ahead and confirm that these are two separate people. The way I can do that is by grabbing their customer ID name as well. So here I'm going to add just two more columns. I'm going to say a.customer ID column, and then I'm going to also add the b.customer ID column here. And then I'm going to go ahead and run this again, F5, or just execute here on the query. And so here I have the customer ID number. So I have 65 matches of customer 157. So these are two separate people, and we're able to match up people that have the first name that matches the last name of someone else in the actual table. Now, using this sort of comma syntax for a self-join statement is pretty common, but I also want to show you how you could use it with just actually explicitly saying join. So that is possible as well for a self-join statement. Some people prefer the way I just did it right now with a comma and the way I showed it in the slides. Other people prefer actually explicitly writing that join statement. And then it would look like this. You would say from customer as A, join customer as B And then instead of saying where, you would say on, first name is equal to last name here. And so if you run that, we get the exact same results. So again, you're going to have to discover your own style as far as what you prefer and what's easier to read for you. I think for a lot of beginners, actually, this second way that I just showed you is usually easier to read and understand, with the caveat being that you're going to use an on statement instead of a where statement. If you prefer thinking about it using from and then the customer as alias, comma, customer as alias, and then using a where statement, that's also totally fine. So again, it's really what you prefer as far as self-join syntax. And then if we wanted to, we could actually continue to work on this query by saying something like order by, let's say, a.customerID. And then we have everything ordered by the customer ID. And you can see here that we're going to get Rose Howard and Darlene Rose, Kelly Torres, Denise Kelly, etc. Now you may be wondering, am I only going to use an inner join by default? What if I wanted a left join or right join? So self-joins are not limited to just an inner join. While the cases we've seen make the most sense of inner join, you can also use a left join to provide all records from the left table regardless if there's actually a match. So if for some reason we wanted to get everything from the left table regardless if there was a match or not, then we can also specify left or right outer joins. So for example, I can edit this and say something like left join. And remember, this is the same as saying left outer join. I can just say left join by default. SQL engines will know you're specifically meaning an outer join because of the term left there. So if I do this and then go ahead and run this, notice that I'm going to get a bunch of null or empty values here because this specific person is from the left table, so the A or customer as A table, and didn't have this first name matching to the last name of anyone else in the table. So we're going to get null values if we do it this way, but as we scroll down, you should see some matches pop up. So for example, Joy George matches with Joseph Joy, so Joy Joy there. So it's up to you and up to whatever the business task that you're trying to solve is, if you're going to use a self-join with an inner join or a left join. More likely than not, you'll usually use these with inner joins because you're specifically looking for some sort of a match there and you don't care about returning everything with the nulls, but it's good to keep in mind that you can use it with left and right outer joins for the tables regardless. Okay, so that's it for the inner joins. What I would recommend doing now is actually Google searching manager plus employee self-join. So if I go ahead and do that real quick. So here I am, I just jumped to Google and I did a manager employee self-join in the Google search. And you'll notice you'll get a lot of results. Go ahead and explore those if you want to learn more about self-join beyond what we just covered here, although it's pretty straightforward as far as you're joining a table to itself. The specific reason I want you to check out manager employee self-join is that for whatever reason, this is an extremely common interview question for people who are going to be interviewed in SQL. It's basically the de facto way to check if you know what a self-join is or not. So basically what happens is you're given this table with employees and managers, and you have to figure out what employees make more salary than managers, etc., that kind of thing. But for whatever reason, this is a really common interview question as far as testing your knowledge of self-joins and subqueries. So go ahead and explore that if you plan on getting interviewed in self-joins or SQL anytime soon. That should probably show up, or some form of that question will show up. Okay, if not, and you understand self-join already, go ahead and feel free to continue on without doing that Google search. Okay, well thanks everyone, and I will see you at the next lecture.